can also visualize what is being done for him. So everything is a vast area whereby the user as well as the person who has the policy, let's say responsibility, everybody understand. Management is also changing with spatial database coming into action, where the management in many countries, including India, was to satisfy the boss always, okay? Satisfy the boss. And actually, the management is changing here, where we are now coming to the issues and the parameters at the grassroots level, where we say yes. Another thing is the management is the process of bringing the journey from there to there actually, and this is what we are trying. When we say we generate database for the whole country, where every village, every well and every farm and every parameter is documented, it is recorded, and we are trying to, let's say, generate information which can be utilized by any general person which is there, okay? This is the journey from here to here, and this journey we are traveling very fast in last 10 years in India, where we are generating a lot of information, which is the digital database which is there. This technology, as Dr. Fabio must have told you, that it helps in many mechanisms which were actually missing in this country. Monitoring. My monitoring was missing. You make canal, but what canal is actually doing, how much benefit is happening, and how much actually the productivity has increased. These types of analysis were not there. They did not actually exist. But with this technology now, with digital data available, we are in a position to actually go back and understand. Transparency is another aspect which is actually guaranteed by this. It's slowly changing, and sometimes I jokingly say that it is also going to fight the corruption, because information is available to everybody very fast, okay, which is there. Many systems are into existence now, which we see slowly in this country, which are running from municipal information system, land information system, which are using the satellite images, information generated through other sources, and the GIS systems. Forget about any analysis. Very simple method whereby we say that when we observe the development in any area, just by using the images which are available at the Google Earth, you can see, for example, one of the area in Nagpur, what changes are happening. So if I show you all the images of the same area in 2000, 2003, 2007, 2012, 2016 and 2020, you find that this area is changing very fast. Now different people will take different information from this analysis which he tries to do. Suppose I am urban planner, I will think whether what are the different things which are going wrong at some places, whether urban planning is happening properly or it is not happening properly. The same image can be seen by the hydrologist in a different way, whether he sees that the different hydrological feature in this area are actually compromised, okay? You can see in this image the river which was flowing in 2003 and having a geometry, that river had all the freedom to actually move in its own way. Now in 2020, the freedom has been taken, and you can see the river is converted into a small stream. Completely, till this point, we have not even done the analysis. We are just seeing the temporal power of this information which is available to us, okay? Now different types of data products are available which are used for global planning, global monitoring, and this data which we are using, downloading, which is freely available, and this data from different satellites, different sensors which are giving different types of parameters, this is available to us, and we are trying to model the different things which are actually, we are in a better position to fight different deficiencies and challenges and disasters which are actually trying to affect our life, okay? Now some case studies I will show very fast, because I think many things have been already discussed by Dr. Fabio. I am here just to let's say share with you how smallest things can be done and how they contribute in some suitable decisions which can be taken by different authorities. Now this was the case study which was done in the BTech project, in third year as a minor project, and we wanted to know that how many structures are there in Nagpur which are within the right of way. Actually the right of way is the road width which belongs to the sector, and where the development activity should not be happening, because this is the area which is required by for development activities, for stormwater, for telephone lines, for electric lines, and so many things. Now in Nagpur, small case study which generated using some basic, let's say, potential high resolution image, and the number of houses which are there within this right of way, and what is the total area of these particular structures, whom they belong to, and actually how much revenue is being lost by the NMC by doing this, how much revenue is actually lost. Very small case study, but it generates something which can be practically used. And it has been used. Means all those case study I am telling, they have been used by the authorities for, let's say, widening and other things which are happening in the city. Another case study which was done by Mr. Rama Rao, who was my student, and Mr. Ajay Kalamdar, who is actually professor in IIT Guwahati now. And Rama Rao he was in UK, and he's recently come to India as a head of the remote sensing division. Now, in 2004, we studied the solid waste management of the city with respect to the generation, the total quantity, the storage, collection, transportation, and disposal of the solid waste. Idea was that which system should be better, because waste management is a ill-structured type of problem whereby n number of parameters actually control this. So many parameters are there which control this, right from the education background of the people and religion of the people, the social structure of the people, everything affects. So these are not only quantities, these are actually the mental setup of the people which controls the solid waste management. So what we did, we performed for whole 10 zones which were present in the Nagpur, we selected some layouts which are belonging to different categories of the land use. These are the 10 land use categories which were actually classified. And for every category, a solid waste characterization was performed. For every built up category, what is the solid waste? Now this characterization was done in 50 parameters which were tested in the lab. So Ajay Kalamdar worked in the lab and Rama Rao worked in the software domain. Two together generated this system whereby we characterized all the parameters. The populations were also generated using this high resolution image by generating small algorithm, and then the different parameters were the regression and coefficients were generated, and finally different parameters which were found for Nagpur were actually transferred. Now all these information which was there using the 50 parameters of solid waste, they were handed over, this whole system was handed over to one organization which was managing the solid waste in Nagpur city, which was CDC from Jaipur. And after this study, it was decided that the bin collection will be actually stopped and door-to-door collection will be started in Nagpur. Okay, so we are very thankful to CDC also for providing the manpower for collection of the samples, collection of the data, and other things. And finally, this comes as a system, spatial decision support system. If you input the 10 built up categories for any city, this system will generate all the relevant information which will be used for solid waste management in any particular area, right? So third case study, another running problem in city, all urban areas, is that the groundwater levels are declining, and where should be the recharge done, where the recharge should be done, who should participate in this recharge, and where the recharge should be done. Now for this, characterization of the aquifers is very important, the surface topography is important, the land use is important, the soil type is important, and then the total groundwater dynamics in this region is important, how much actually groundwater shifting is happening. So we identified 74 wells in the urban area and they were monitored for 4 years. Now Central Groundwater Board was not monitoring urban areas before that, but with my student taking, my PhD student becoming the regional director of the CGWB, so we started urban monitoring after this case study, and now in India the urban situations are also monitored. What was the result of this is that in city, Nagpur city, the green spaces are the spaces, green points are the areas where the groundwater is not declining, and red points are the area where the groundwater is declining, and where the red areas are there the rooftop rainwater harvesting should be actually adopted. And we requested the municipal corporation that they should be given rebate in their tax, property tax, all those people who are actually resorting to the rooftop rainwater harvesting. This is the strategy. Okay. Next case study was in a mining area. One of my student who is scientist in one of the CSIR lab in Bhubaneswar Dr. Deepti Ranjan Satpathy. He did this case study and we generated one spatial decision support system for sustainability of the environment which was there, starting from the basic parameters of elevation, slope, aspect, etc., and the different groundwater and surface water parameters of the pollution which are there. Because this particular area, city, is having lot of activities which are happening in this city. There are mines, there are thermal power stations, there are cement industries, there are iron industries in Chandrapur. So the environment was actually affected a lot in different sectors. So ultimately, idea was to generate a decision support system which will guide these organizations what should be done. And ultimately, this decision support system worked in different environments like land environment, water environment, air environment, and generated information about different environments. And finally, it gave you the areas which are challenged. In red color, you see the areas where the environmental sustainability is compromised a lot. So what are the reasons for this? We identified which organization is actually responsible for this, and that organization should be doing the measures, mitigation for actually stopping this degradation of the environment. So this was the objective of this particular MISA SDSS 1.0 generated by my student Deepti Ranjan Satpathy. Okay. Another thing was Irai watershed. This was done by my another student who is now director of Maharashtra Remote Sensing Application Center, and he did this work in Irai watershed where the dumps which are there, the coal mining generates dumps. Dump is actually loose material, and this loose material actually drains out in the particular monsoon season and deposits at the river. Okay, this process is so fast that the erosion which is happening because of this and the deposition is mesmerizing. So we understood the 3D modeling of the whole area and understood in 2008 there was a flood because of this. The Chandrapur city have never had any flood, but for the first time the flood was there because the rivers had become narrow, and because of this. We also generated one algorithm whereby in such areas the sedimentation yield can be calculated. We can estimate the sediments which are generating because of the formation of the new type of hydrology completely, which was not existing before this particular phenomena, because morphology is being changed. Next case study is because of Mihan area. Now Mihan area is in Nagpur, which is an industrial area. This is industrial area. 5,000 hectares of land has been demarcated to industry and software industry. Now this is a new area, new dream of our bureaucrats. They want to have all activities in the Nagpur. This is a central area. But we did a study that if Mihan works 100%, then what would be the environmental situation there? Okay, how much water will be required? How much solid waste will be generated? How much sewer will be generated? And what will happen? Where this sewer will go? Okay, where this quantity will go? Interestingly, the reservoirs which are there. Now these are the different buffer zones around the Mihan area. Now you'll see there are so many water reservoirs here, and the biggest reservoir is in the south, which is seen half there. Now this is Vadgaon reservoir. So interestingly, what we found that the Vadgaon reservoir was thought to be the supplier of the water to Mihan area, and whatever sewage is generated because of development in Mihan is also going to the same reservoir. So this is a situation which is very strange and very interesting, and we informed the authorities that something should be done. Where the sewage treatment plant should be located, where the sewage should be arrested, collected, so that this situation does not arise. Okay. So we started with land use map of 1998, 2008, and from these two maps we generated situation of 2020 and 2030. The populations were also generated because of the development which is happening here, and we understood that this area is going to be the hub area in the coming times. Now in 2020 we checked what we calculated, the population is actually matching there with 3 or 4% of difference here, and in 2030 also the land use map of 2020 is matching, and 2030 I don't know whether it 100% matches in after 5 years or not, but with the development which is happening in this area, certainly things will be like that. Another case study which was done by one of my student who is a scientist in NIRI now, Dr. Sangeeta Ghadge. She did about the urban heat island in Nagpur, whereby we used the thermal data, and using thermal data we generated the urban heat islands in the Nagpur and correlated this data basis with the land use and the materials which are present in different construction industries, and tried to find out the ambient temperature changes which are there. We found that one small island can be identified in the east north Nagpur, where the Itwari Mahal area is there, and the west Nagpur was still free of any heat island effect. But now this study was done 10 years back, 10, 12 years back. Now if we do, I think the western area is also actually gripping in the heat island effect. Next case study is infiltration using the remote sensing data and using the reservoir frequency. Sir, there is a district close to Nagpur, which is Bhandara, and this Bhandara district has 3,000 reservoirs. 3,000 reservoirs. And Nagpur doesn't have so many reservoirs. So I was astonished why there are 3,000 reservoirs in Bhandara district. So I found that the soil type is different in Bhandara. There is one mineral in the soil which is feldspar, which is not present too much quantity in Nagpur. So this is the difference, and it makes the soil completely impermeable, and that's why surface storage is too much. Okay. Now using the infiltration, I thought why not generate the infiltration amount from using this information. So what we did, we monitored the surface water spread in different reservoirs monthly, every month. What is the change which is happening? And some reservoirs where we found where they became dry in the month of January, some of the reservoirs they dried in month of the April, etc. And using this, we generate a system whereby using the reservoir frequencies which were having water, we generated the infiltration capacity of the soil. So this was the objective. This work was done by Dr. Tampasana Thiyam Devi. She is actually head of department of NIT Manipur, head of the Department of Civil Engineering now. She did MTech with me. I told you, my students have become big. Okay, the teacher remains there, but the students have gone, they have become big. Now, Tapasana Devi was, together, me and her, we got gold medal at the hands of Shri Narendra Modi for this work, for outstanding work in the Geospatial Forum. Okay, so this was thought to be a very new type of activity which is there. So we generated all the parameters pertaining to Bhandara district, the land use and other things, the soil, the reservoirs and the frequencies which are there in different watersheds, and finally worked out the total infiltration capacities using the AHP, overlay analysis and other techniques which are there. Next case study is payment information system. This was done by Mr. Harshal Kadak in 2012. And Harshal is actually professor in Bhopal Engineering College, and what we tried to do is the different roads and their service levels which are there. We should have an information system so that we can utilize the fund properly for repairing the different roads which are at the distress, where it should go, where the money should go. And this we did for all the major roads in Nagpur, the level of service of different roads, and beautiful techniques were used whereby we use the images, we use the videography also. We tied up videography with the GIS database, and now we know that there are LIDAR sensors also which can be used for actually monitoring the surface topography and surface distresses. Several types of distresses were actually monitored in this study, and ultimately the system gives the status of all the road with respect to these distresses, and finally you could have actually, if you click at the road, you could get the photograph of that area also. This was the system which was generated at that time. Okay, and the level of service of different roads was the final objective, which is the road which is at the worst condition of the level of service of the road, so that money should go to that road. Okay. Now another last case study, the impacts of climate change on ground. Now we are working in the climate change area, so many of them. This thing includes case study of my 3 students, 2 or 3 students. Okay, Rishma is actually working as a scientist in UK, one of the let's say institute, and Rajeshri Botle is actually director of ISRO. Okay, these students actually they worked for this, and they are doing a very good job there. Now these 2 case studies impacts. We are interested that Central India and the basins in Central India, whether they are really affected by the global climate change. This is the question which is in my mind. And whether the GCM, that the global climate models which anticipate and actually predict many things out there, whether we can match those or testify those on the ground micro level, whether really these things are happening at the instead of ENSO mechanism, that is El Nino, La Nina, and Indian dipole, actually positive and negative dipole. These are the phenomena which are there. So we found out that Rajeshri worked on the Pranhita Godavari basin, and Rishma worked on the Vena river basin, and the two basins we worked with very simple criteria. What is happening to the impact parameters in these two regions using remote sensing data? What is happening to the rainfall distribution, the runoff which is there, okay, then the vegetation index which is there, the water index which is there. All these things were generated, and finally what is happening in the command area, what is happening in the non-command area, and compare the two things, and finally make the models. Another thing which we wanted to address through this case study was that there are many farmer suicides in Vidarbha, so many farmer suicides. Why these suicides are happening, and whether it is something related to the global climate change systems which are there. So what we did, we took the data of the suicide numbers in Amravati, Nagpur and Bhandara districts and other districts, and we tried to match up with the phenology of the crops which is happening in this area. Now phenology of the crops can be monitored by remote sensing data by the NDVI. Now we use the MODIS data which gives you every 16 days the NDVI values, and these MODIS data products. Now what is happening? Very interesting facts come out. Like in El Nino, which is the one component of ENSO, where there is deficiency in rainfall. Okay, deficiency was not there, but only thing, the time of onset of monsoon was changing, and this onset was disturbing our farmers, which is happening actually. So what is happening in El Nino year? The rainfall happens in the February, March and April month. Some rainfall is there, and there is a sudden block of rainfall in July month. There is no rain in July month, and this is the time when the farmers they do the sowing in the June end month and in July first week and the second week and third week of June. This is the time when they do sowing, and when they have sown, the rainfall stops, and their whole thing is actually lost. And they have to go for re-sowing, and then he takes the money from somebody and things like that. So yes, the global climate change is affecting this phenomena, and yes, what should be done? We should train the farmers that this is El Nino year, don't sow this thing, wait for the July month, take it easy, okay, enjoy your life, and use varieties which can be a faster growing varieties, which can be 2 years, 3 months or 2.5 months type of varieties of paddy and other things which can be there. Now this information has been passed to the agriculture department, and I am very happy that agriculture department is working on this through their extension departments, this information. So several other special things have been done, and we see the impacts in the command area and non-command. So command area will not show the impacts of the global climate change because it is irrigated. And non-command areas, we should focus our studies in non-command areas only, because those will only show the impacts, whether the impacts are happening or not. Okay. Oh, there are few more studies. So one or two. Should I stop or? Okay. So now GRACE data we also utilized. GRACE data which is giving you the groundwater, some groundwater. Now the resolution of the GRACE data is very coarse nowadays, but new products are coming which tell us about the groundwater storage in any area. So we did two things. First of all, we wanted to validate whether the GRACE data is showing the right things or not. Okay, whether the values of GRACE data can be believed or not. This is the first thing. And second thing, what happens to the sensitivity of the GRACE data when the aquifer type changes? Okay, the two things were there. Now, two people worked on this. One was Kaushalendra Verma. Now, I'm very happy to tell you that now Kaushalendra is in France, and he's working in the same satellite he worked with in the same company. And he's trying to work on the new dimensions of this area, which is there. Okay, so what we did, we selected the Vidarbha region, and we mapped all the aquifers which are present in Vidarbha region, all the aquifers. And then for every aquifer, we use the GRACE data. We took these points, and you see the color which is changing of the points is actually change in the aquifer material. Now different aquifers have different properties. Okay, they have porosity changes, permeability changes, storage coefficient, yield and other things which change, which are hydrological parameters. And we found out whether the GRACE data is catching these changes which are happening in the aquifer, whether it catches that. If it catches, then this type of case study for different types of aquifer was done, and then the case study was extended to this whole state where the different types of aquifers are there. And these two case studies were done. I am not remembering the first name. Chandan, yeah. The first name was Chandan, who did the first study, and second case study was done by Kaushalendra Verma. Dr. Kaushalendra Verma, he did his PhD from IIT Mumbai, and then he's in France today. Okay. Now, infrastructure versus urban flood. Mr. Mukesh did this study, Dr. Mukesh rather, and this is again done. Again, interesting phenomena that why urban areas are facing floods today. Why floods are happening in urban areas, and what is happening wrong in Nagpur. Okay, that is the thing which is happening. So we started with the basic things. We use the Sentinel data of 10-meter resolution and the DMs which are there, which are available. Then we generated our own DM, which was used, for which we used our own RL values for different roads which are generated in Nagpur. The concrete roads, they raise 1 meter above the basic datum which is there. And what is happening is they are changing the hydrology of the complete urban area. And this hydrology change is not being detected by any development manager. And that's why these problems are actually happening. So what we did, we see it is showing that the roads are higher. The houses are actually almost down, and it is 1 meter above which is there. What this is causing? This is causing water divides which were not there, okay? And the natural stream system is challenged here, completely challenged. It is not working. So this type of things, and we did the flow modeling in the complete area, and this flow modeling was done with respect to the new development in the concrete roads which happened in Nagpur. And finally, we found out that the roads before this development in 2010 and the situation of 2018 and 20, what is happening there? We found that more roads are coming into flood prone vulnerability index rather than the roads which were there in 10 years back. Okay, so you can see we used another concept of centrality. Centrality means the shortest route which is available to anybody, which is there. So centrality concept was used in flood mapping here, and we found that what is the effect to the centrality which is happening in Nagpur district because of the urban floods which are happening in pockets in different areas. Now floods come generally, natural floods come when the river actually breaches its boundaries. But these floods are not because of the river boundary, they are because of the poor urban development which is happening in Nagpur district. Okay. So, okay, one more is there. Overexploited watershed. Now this, where you have watershed which is overexploited, when it becomes overexploited, certainly everything stops. So how to rejuvenate that? How to rejuvenate an watershed whereby the farmers can actually go back to the situation which was 30 years or 40 years back. So that is the thing. So what should be done? Now two people worked on this. One was Bhushan Lamsoge, who is a scientist in Central Groundwater Board. Another was Mr. Bhusari, Dr. Bhusari rather. Now he was scientist in actually State Groundwater Board. And these two people worked and generated techniques whereby recharge can happen in different situations of aquifers. So this case study was adopted again, and different data generated, analysis, identified areas which are actually going into the red region, etc. And the modeling was done to again take the complete watershed into the back situation. So what should be done? How much recharge should be done? Where it should be done? These were the questions. And in this process, we generated new technique, which was a new structure, which was reverse gradient recharge mechanism. Okay. Now this reverse gradient recharge mechanism is, for this particular mechanism, this paper was also awarded Best Paper Award in the International Guild of Publication because Mr. Bhusari did a beautiful work by going to. Now what is more satisfying is this technique is adopted by state government, and they have constructed these structures in several villages which are facing water scarcity problem. Okay. So just to tell you that this technology is related to governance directly, to take decisions at the right time, at the right places. And if we strengthen this technology, make more and more use of this technology, I think we will be in a position to contribute to some extent to the quality of life enhancement in this country. Thank you. Thank you very much. Thank you. Yeah, you can have. that's why he was telling you, no? I mean, in 5 days, use more and more of data, use more and more of satellite data. And several products are available today. There are several products which are there, which you can freely download and you can use those products and you can find. And now so many techniques are also there. Google Earth Engine is there, and so many things where you will require some training on that to master that. But those are actually really giving you a lot of this thing. We just started working on AI, etc. We predicted the monsoon for central India using AI technique, but we are not very good at these things. I mean, we would like to have the help of Deep and other people. I mean, I am not a master in AI and machine learning, etc. But I can tell you 100 areas where this can be applied. So that is the basic thing. Thank you. Thank you. Lunch the menu. Sorry, I don't eat outside. I don't eat outside.